Hello everyone. Today we are gonna read the book Cosmos by Carl Sagan. So let's get on with it. The introduction. The time will come when diligent research over long periods will bring to light things which now lie hidden. A single lifetime, even though entirely devoted to the sky, would not be enough for the investigation of so vast a subject. And so this knowledge will be unfolded only through long successive ages. There will come a time when our descendants will be amazed that we did not know things that are so plain to them. Many discoveries are reserved for ages still to come, when memory of us will have been effaced. Our universe is a sorry little affair, unless it has in it something for every age to investigate. Nature does not reveal her mysteries once and for all. Said by Senecia, Natural Questions, Book 7 of the 1st century. In ancient times, in everyday speech and custom, the most mundane things happening were connected with the grandest cosmic events. A charming example is an incantation against the worm which the Assyrians of 1000 BC imagined to cause toothaches. It begins with the origin of the universe and ends with a cure for toothache. After Anu had created the heaven, and the heaven had created the earth, and the earth had created the rivers, and the rivers had created the canals, and the canals had created the morass had created the worm. The worm went before Shamash, weeping, his tears flowing before Ea. What wilt thou give me for my blood? What wilt thou give me for my drink? I will give thee the dried fig and the apricot. What are these to me, the dried fig and the apricot? Lift me up, and among the teeth and the gums let me dwell, because thou hast said, O worm, may I smite thee with the might of his hand. These were the incantation against toothache. Its treatment, second-grade beer and oil, thou shalt mix together. The incantation, thou shalt receive 3 times thereon, and shalt put the medicine upon the tooth. Our ancestors were eager to understand the world, but had not quite stumbled upon the method. They imagined a small, quaint, tidy universe in which the dominant forces were gods like Anu, Ea, and Shamash. In that universe, humans played an important, if not a central, role. We were intimately bound up with the rest of nature. The treatment of toothache with second-rate beer was tied to the deepest cosmological mysteries. Today, we have discovered a powerful and elegant way to understand the universe, a method called science. It has revealed to us a universe so ancient and so vast that human affairs seem at first to be of little consequence. We have grown distant from the cosmos. It has seemed remote and irrelevant to everyday concerns. But science has found not only that the universe has a reeling and ecstatic grandeur, not only that it is accessible to human understanding, but also that we are, in a very real and profound sense, a part of that cosmos. Born from it, it's our fate, deeply connected with it. The most basic human events and the most trivial trace back to the universe and its origins. This book is devoted to the exploration of that cosmic perspective. In the summer and fall of 1976, as a member of the Viking lander Imagine Flight team, I was engaged with 100 of my scientific colleagues in the exploration of the planet Mars. For the first time in human history, we had landed 2 space vehicles on the surface of another world. The results, described more fully in Chapter 5, were spectacular. The historical significance of the mission utterly apparent, and yet the general public was learning almost nothing of these great happenings. The press was largely inattentive. Television ignored the mission almost altogether. When it became clear that a definitive answer on whether there is life on Mars would not be forthcoming, interest dwindled still further. There was little tolerance for ambiguity. When we found the sky of Mars to be a kind of pinkish yellow rather than the blue which had erroneously first been reported, the announcement was greeted by a chorus of good-natured boos, and the assembled reporters, they wanted Mars to be, even in this respect, like the Earth. They believed that their audiences would be progressively disinterested as Mars was revealed to be a less and less like Earth. And yet the Martian landscapes are staggering, the vistas breathtaking. I was positive from my own experience that an enormous global interest exists in exploration of the planets and in many kindred scientific topics. The origin of life, the Earth and the cosmos, the center of extraterrestrial intelligence, our connection with the universe. And I was certain that this interest could be excited through the most powerful communications medium, television. My feelings were shared by B. Gentry Lee, the Viking data analysis and mission planning director. We decided gamely to do something about the problem ourselves. Lee proposed that we form a production company devoted to the communication of science in an engaging and accessible way. In the following months, we were approached by a number of projects. But by far, the most interesting was an inquiry tendered by KSET, the public broadcasting services outlet in Los Angeles. Eventually, we jointly agreed to produce a 13-part television series oriented towards astronomy but with a very broad human perspective. It was to be aimed at popular audiences, to be visually and musically stunning, and to engage the heart as well as the mind. We talked with underwriters, hired an executive producer, and found ourselves embarked on a 3-year project called Cosmos. At this writing, it has an estimated worldwide viewing audience of over 200 million people, or almost 5% of the human population of the planet Earth. It is dedicated to the proposition that the public is far more intelligent than it has generally been given credit for, and the deepest scientific questions on the nature and origin of the world excite the interests and passion of an enormous number of people. The present epoch is a major crossroad for our civilization and perhaps for our species. Whatever road we take, our fate is indissolubly bound up with science. It is essential as a matter of simple survival for us to understand science. In addition, science is a delight. Evolution has arranged that we take pleasure in understanding. Those who understand are more likely to survive. The Cosmos television series and this book represent a hopeful experiment in communicating some of the ideas, methods, and joys of science. The book and the television series evolved together. In some sense, each is based on the other. Many illustrations in this book are based on the striking visuals prepared for the television series. But books and television series have somewhat found audiences and admit differing approaches. One of the great virtues of a book is that it is possible for the reader to return repeatedly to obscure or difficult passages. This is only beginning to become possible with the development of videotape and video disc technology for television. There is much more freedom for the author in choosing the range and depth of topics for a chapter in a book than for the Procrustean 58 minutes 30 seconds of a non-commercial television program. This book goes more deeply into many topics that does the television series. There are topics discussed in the book which are not treated in the television series and vice versa. For example, explicit representations of the cosmic calendar featured in the television series do not appear here, in part because the cosmic calendar is discussed in my book, The Dragons of Eden. Likewise, I do not here discuss the life of Robert Goddard in much detail, because there is a chapter in Broca's brain devoted to him. But each episode of the television series follows fairly closely the corresponding chapter of this book. And I like to think that the pleasure of each will be enhanced by reference to the other. Only a few of them of more than 250 full-color illustrations in the hardbound and trade paperback editions of Cosmos could be accommodated in this edition, but all illustrations necessary to understand the text are included. For clarity, I have, in a number of cases, introduced an idea more than once, the first time lightly and with deeper passes on subsequent appearances. This occurs, for example, in the introduction of cosmic objects in Chapter 1, which are examined in greater detail later on, or in the discussion of mutations, enzymes, and nucleic acids in Chapter 2. In a few cases, concepts are presented out of historical order. For example, the ideas of the ancient Greek scientists are presented in Chapter 7, after the discussion of Johannes Kepler in Chapter 3. But I believe an appreciation of the Greeks can be best provided after we see that they barely missed achieving. Because science is inseparable from the rest of the human endeavor, it cannot be discussed without making contact, sometimes glancing, sometimes head-on, and with a number of social, political, religious, and philosophical issues. Even in the filming of a television series on science, the worldwide devotion to military activities becomes intrusive, simulating the exploration of Mars in the Mojave Desert with a full-scale version of the Viking lander. We were repeatedly interrupted by the United States Air Force performing bombing runs in a nearby test range. In Alexandria, Egypt, from 9 to 11 a.m. every morning, our hotel was the subject of practice strafing runs by the Egyptian Air Force. In Samos, Greece, permission to film anywhere was withheld until the very last moment because of NATO maneuvers and what was clearly the construction of a warren of underground and hillside emplacements for artillery and tanks. In Czechoslovakia, the use of walkie-talkies for organizing the filming logistics on a rural road attracted the attention of a Czech Air Force fighter, which circled overhead until reassured in Czech that no threat to national security was being perpetrated. In Greece, Egypt, and Czechoslovakia, our film crews were accompanied everywhere by agents of the state security apparatus. Preliminary inquiries about filming in Kaluga, USSR for a proposed discussion of the life of the Russian pioneer of astronautics, Konstantin Tsiolkovsky, were discouraged because, as we later discovered, trials of descendants were to be conducted here. Our camera crews met innumerable kindness in every country we visited, but the global military presence, the fear in the hearts of the nations, was everywhere. The experience confirmed my resolve to retreat when relevant social questions, both in the series and in the book. Science is an ongoing process. It never ends. There is no single ultimate truth to be achieved, after which all the scientists can retire. And because this is so, the world is far more interesting for both the scientists and for the millions of people in every nation, who, while not professional scientists, are deeply interested in the methods and findings of science. So, while there is little in the Cosmos book that has become obsolete since its first publication, there have been many insignificant new findings. The Voyager 1 and 2 spacecraft encountered the Saturn system and uncovered a host of wonders concerning the planet, its integrated ring system, and its swarm of attendant satellites. Perhaps most interesting of these is Titan, which is now known to have an atmosphere rather like that of the primitive Earth, a dense haze layer composed of complex organic molecules, and perhaps a surface ocean of liquid hydrocarbons. A range of observations have recently been made of rings of debris surrounding young stars. These rings may be in the process of coagulating into a new planetary system, and suggest that planets may be overwhelmingly abundant among the stars of the Milky Way galaxy. Life has been found unexpectedly nibbling on sulfur compounds in very high temperature vents on the Earth's ocean floor. New evidence has accumulated suggesting that comets are periodically spread into the inner solar system, triggering the extinction of many species on Earth. Great regions of intergalactic space have been uncovered that seemingly are depleted in galaxies. New and important components of the universe bearing on the question of its ultimate fate have been suggested. And the pace of discovery continues. Spacecraft of Japan, of the European Space Agency, and of the Soviet Union are scheduled to intercept Halley's Comet in 1986. The US Space Telescope, the largest orbiting observatory ever attempted, scheduled to be launched before the end of the decade. Important opportunities for spacecraft missions to Mars, to other comets, to asteroids, and to Titan are emerging. The US Galileo spacecraft, scheduled to arrive in the Jupiter system in 1988, is designed to drop the first entry probe into the atmosphere of one of the giant planets. And there is a somber side to the pace of scientific discovery as well. Recent work suggests that in the aftermath of a nuclear war, the resulting soot and dust lofted high into the atmosphere would darken and freeze the Earth, producing an unprecedented catastrophe, even for nations on which not a single bomb has fallen. Our technology is increasingly permitting us to explore the wonders of the cosmos and to reduce the Earth to chaos. We are privileged to live in, and if we are lucky, to influence one of the most critical epochs in the history of the human species. On a project of this magnitude, it is impossible to thank everyone who has made a contribution. This introduction to the book Cosmos by Carl Sagan was written by Druyan.